Okay, Assalamualaikum and hi everyone. So today we are going to continue into the second subtopic, which is we are going to find a vertical and horizontal asymptote. So I think by now you should know what is an asymptote. So basically for chapter 8 limits, vertical asymptotes, we are going to use this case 3 here, and a horizontal asymptote, we are going to use case 5 here. So from your prior knowledge from 8.1, this is what we are going to do. So this is your vertical asymptote and this is your horizontal asymptote. Okay, so let's take a look at our example here. So let's see 8.2, we're going to find vertical asymptote first. So as I said earlier, this is your case 3, okay, where your limit fx when x approaches to a, you are going to get positive or negative infinity. Okay, so let's see. Let's just go straight to the example. Example 13. Determine the vertical asymptote of x plus 3 over x plus 2. Okay, yes, we know by looking at the chapter 5, we know that your x equals to negative 2 is a vertical asymptote. Okay, but for chapter 8, we have to verify that that is a vertical asymptote. How? How? Sedap. How? So we know that first, we know that this is a vertical asymptote. Okay, we know that our vertical asymptote is by looking at the denominator. X plus 2 is not equals to 0, so x is not equals to negative 2. Okay, we know that this is a vertical asymptote. But for chapter 8, you have to verify that that is your vertical asymptote. Okay, so you have to see the limit from the right and from the left, which means you have to see your x approaches negative 2 from the right is equals to x approaches to negative 2 from the left. Okay, it's either equal. I mean, if you get positive infinity, negative infinity, it is still a vertical asymptote. Okay, so let's see. If we have limit fx, our fx is x plus 3 over x plus 2 when x approaches to negative 2 from the right. Okay, like I said in the previous video, just draw your number line. This is your negative 2, this is negative 2 positive from the right, this is negative 2 from the left. So this should be negative 1.9 and this should be negative 2.1. Okay, so this is your case 3. So we are going to just substitute the value. So if you substitute the value of negative 2 into this one, you are going to get negative 2 plus 3, which is we have 1. Okay, just substitute negative 2 plus 3, we are going to get 1. But for the denominator here, we want negative 2 from the right. Okay, so we take this value here, negative 1.9. So we have negative 1.9 plus 2, which is we get a positive value. Okay, that means your answer is 0 from the right. Okay, so the answer here is 1 over 0 from the right, which is we get positive infinity. Okay, so next, you must also show limit from the left as well. Limit x approaches to negative 2 from the left. We have a function x plus 3 over x plus 2 equals to negative 2 plus 3. So here we have negative 2 from the left. From the left, we have negative 2.1. So negative 2.1 plus 2, we have a negative value. Okay, so that means this is a 0 from the left. So we have 1 over 0 from the left. So the answer here is negative infinity. Okay, it's either this one positive infinity, negative infinity, or if you get positive infinity, or you get both negative infinity, your answer, your vertical asymptote is still considered as vertical asymptote. So here you have to write the conclusion. X is equals to negative 2 is a vertical asymptote. Okay, so next, let's take a look at example B. We have fx equals to 2x over x squared minus x minus 2. Okay, so now what is the vertical asymptote here? Okay, by using your prior knowledge from chapter 5, we know that our vertical asymptote, we have to do x squared minus x minus 2. We know that the denominator is not equals to 0. So we have to factorize this. We get to 1 minus plus. Okay, so we have x is not equals to -1 and x is not equals to 2. Okay, so you have two values here, two values of x. So you have to apply both of this value here. So first, let's do for when x equals to -1 first. So let's draw a number line. So this is -1, this is -1 from the right, -1 from the left. This is negative 0.9, this is negative 1.1. Okay, so let's find limit from the right and limit from the left. Limit to x over x plus 1, x minus 2, when x approaches to -1 from the right. Okay, so -1 from the right is negative 0.9. Okay, so if we substitute -1 here, we get -2. Okay, is it correct? Yes. So we have negative 2 times -1 over. So here -1 plus 1, we get 0. So is it 0 positive or 0 negative? Here is -1 from the right, which means we have to take negative 0.9. Negative 0.9 plus 1, so should get 0 positive. So here is 0 from the right. Okay, for this one, just substitute as usual. -1 minus 3, which is we get -1 minus 2, which is we get -3. So the answer here, just take all the sign here. We have negative value here, negative value, positive, negative. That means negative, negative, we get a positive value. So your answer is positive infinity. Okay, just bayangkan yang this is a sign, a positive sign. Okay, so let's see for limit fx when x approaches to -1 from the left to x over x plus 1, x minus 2. So here should be the same, 2 times -1 over. So -1 from the left. So here -1 from the left, we take the value of -1.1. -1.1 plus 1. So the answer is 0 from the left. 0 from the left. So here is -3. So here your answer should be -2 over this one negative, this one negative, it is positive. So here is negative infinity. Okay, so we can already conclude that x equals to -1 is a vertical asymptote. Okay, but you still have to do for x equals to 2. Okay, let's write with another color here. So we have when x equals to 2, just do like exactly the same thing. 2x, x plus 1, x minus 2, when x approaches to 2 from the right. So let's draw a number line. We have 2. This is 2 from the right, this is 2 from the left, this is 2.1, this is 1.9. Okay, so here we have 2 times 2 over 2 plus 1. Here is we get 3. Here 2 times 2 as 2 minus 2, we get 0. We want 2 from the right, so we take value 2.1. 2.1 minus 2, we get a positive value. So this will be 0, positive. Okay, so positive, positive, positive. So here we are going to get positive infinity. Okay, jangan confuse. Memang kita akan dapat 4 over 0 positive. That's why we get positive infinity. Okay, so last one we are going to do limit x approaches to 2 from the left to x over x plus 1, x minus 2. So here 2 times 2, here is still 3. And here we get 2 from the left. That means we have to substitute 1.9. 1.9 minus 2, we get a negative value. That means this is a 0 from the left. Okay, so we have 4 over 0 from the left. That means here is negative value for positive over negative. So you have negative infinity. Okay, so now we have to write the conclusion. We have x equals to -1 and x equals to 2 are vertical asymptotes. Okay, very very easy. Okay, so sebenarnya kita just verifykan yang apa yang kita ada, X yang kita ada ialah vertical asymptote by just looking at our limit X approaches to A positive and X approaches to A from the left. Okay, alright.